All right, welcome back to the brew side of the house and to this presentation on the Keezer build that we just finished. There it is in the center photo, and we're really happy with the way it came out. Behind this whole story is that if you look at the photo in the upper left, that's our trustworthy garage refrigerator that we had for a real long time, and it finally died when it got to be about 25 years old, and we had to figure out what to do next. Well, we could have converted the refrigerator next to it to the same service and used it, but it's the same age, and so it wasn't going to last too much longer anyway. We started thinking about Keezers. Those fridges are in our garage, and in Florida the garage is really hot, and so we decided we needed to have something in the house. Keezers were top of the list for things to do, and if it's going to be in the house, then it has to look nice enough to sit in the living room where it sits. And so there's some furniture making that went along with this. Huge challenge for us. We looked online for some how-tos on how to do Keezer with a tower design on top, with the faucets on the tower. Couldn't find a lot. For the standard design with the collar and the faucets on the collar, there's a lot of that out there. That's a little more straightforward than this. And so we thought we'd put together this presentation not only to show you the process we followed, but to maybe give you some insight as to the things that we learned when we went through this. Here's a list of the major parts. I'm not going to read it to you, but I want to highlight a couple of things for you real quick. Number one is that I learned doing my research that circulation of the cold air inside the freezer, especially when you have a tower and circulating cold air through the tower, is super important to good operation. So we used a converted PC fan, there it is in the lower right hand corner, and a power supply that I took, I think it was from a cell phone charger or something, but it put out 12 volts DC at 1 amp, and it was enough to run the fan in the right direction. So simple wiring project there. The biggest research project we did, though, was on the controller, and we finally chose the Johnson A421. I'll tell you, I'm really happy that we decided to do that. It's super easy to use. It is definitely plug and play. You don't have to modify anything electrical on the freezer at all. And you can just plug the freezer into it and program it. Very easy to program. One-page piece of paper that tells you how to do that. It's super easy. So I would recommend that. I know there's others out there too. This one was about $79. Bought it on Amazon. The lumber, we used standard 2x4s for the base, and then all the furniture type stuff was 1/4 inch birch faced plywood for the side panels with 1x3 poplar rails, and the top was a 1/2 inch 2x4 sheet of oak faced plywood with the same rails poplar as the sides. No special tools really required. You need a good table saw so you can make nice square cuts on the plywood, and a good chop saw to help you make consistent cuts on the dimensional lumber. Everything else pretty straightforward. I'll tell you, having a power sander is very helpful to this. If you're sanding by hand, it's going to take a while. So if you're going to buy a tool, that might be the one you need. Started construction with the base. Photo on the left, you can see what the base looks like and the location of the wheels. One lesson I learned was that if you place the wheels on the side rails like I have there, it puts the whole thing closer to the floor, which is good. You don't have to cover a big gap at the bottom with any extra skirting or anything, so that was nice. However, if you need to make sure that you place the wheels so that when they swing around, they don't hit on the other rails or the side panels when they come down. I had to move the wheels once because I didn't account for the side panels before I put them where they are. Couple good things to note on this slide. The first one, there's 3 panels on the sides, or 2 on the sides, 1 on the front, 3 panels for the lower section. I screwed exactly 1 piece of lumber onto the freezer, and I really worried about it because I had to drill holes in the sides of the freezer to accommodate it. And that 1 piece is the red arrow on the right-hand photograph. You can see it there. It's a piece that goes side by side just below the lid, and it holds the top of the front panel in place. I really worried about drilling into the front of the freezer like that. I did a lot of research on where the internal parts are. I finally decided that it was okay to do so, but still I was very scared when I did it. Later I learned about better clamping techniques and the use of construction adhesive, which we did use on all the other wood that attaches to the freezer. And if I was going to do it again, one of the things I would change is I would not drill those holes. I could just glue everything on with construction adhesive and it would hold on just fine. In the left-hand photo, take a look at the red circle. That's where the temperature control is for this freezer. Yours might be different, but if you're going to cover it up with a panel, make sure you put it where you want it to be now before you cover it up. I wasn't sure where to put mine, so I just turned it all the way up. It seems to be working fine like that. And then if you look on the lower right-hand photo, you can see there was an access port where the power cord came out, and that was a plastic cover that was on there that I removed as well. That opens up an air channel that goes into the compressor compartment, and now I want to talk to you about airflow. It's really important that your compressor has airflow through it so that it can stay cool. On this freezer, because I was able to remove that panel on the back, if you look at number 1, the air now flows in the rear opening. It goes into the compressor compartment, and then it comes out. If you look at the photo on the right, there's a big gap at the bottom there where there was a grating that covered that up. I removed that grate, and the hot air now flows out there. And then it flows, number 4, up through the air channel that's between the side panel and the side of the freezer, and out the gap at the top, which is number 5. Your freezer will probably be different than this, and so I can't say exactly how you should do yours, but I would say that make sure you think about airflow and how the air is going to flow in and out of your Keezer, and make sure you provide for it so that your compressor can stay cool. Panel installation was pretty straightforward. We did have that one piece at the top that attached the front panel to, and the bottom of the front panel attached to the base. Those were glued, and the base was dimensioned so that with the support at the top, the panel was nice and level, or plumb, when it was installed. Side panels attached to the end of that top support piece, the edges of the front panel, and the base as well. And then on the right-hand photograph, if you look at the red arrow on the right side of the photograph, that's a 2x4 that I put in place in the back so that you could support the side panels as well. And that 2x4 and the one on the other side, they're both held in place just with construction adhesive. I used liquid nails, and it worked great. No problems at all. Didn't have to do any special preparation to the surface of the freezer. It sets up overnight. It's kind of gummy when it first starts out. It eventually gets pretty hard though, and it's super sticky and holds the wood to the metal very nicely. For the front corners, because I'm not a fancy cabinet maker and didn't really think about how I'd overlap the panels, you can see on the right hand photo how in the front corner there's the 2 edges, and it's kind of open in the back. So in the left hand picture at the arrow, you can see I just ripped pieces of 1/2-inch square poplar from the trim I had and put those on the corners. I put those in with glue and some finish nails, and then I removed the nails after the glue dried, and it ended up looking just fine. Last thing, on the right hand picture, you can see there's the door handle on this one, and the top of the door handle goes above the top surface of the door, so that if I didn't do something about that, when I put the piece of wood on top for the top surface, it wouldn't be flat. So what I was able to do was take a utility knife and cut the front edge of the door handle just below the top surface, take off the top part of the handle, the bottom part stayed in, and it didn't make any air leaks or anything like that in the door, so it remained good insulating. And that gave me the flat surface I needed. Again, your door handle might be different. You might have issues with the hinges as well. The hinges on this one were below the top surface, so not an issue there. The top construction is a piece of 1/2-inch oak-faced plywood. Used 1x3 supports on the back of it so that it would be nice and strong as a surface. Biggest thing I learned while doing the top was test your fit. Often I had to make some adjustments to it so that it would fit squarely on the top on the door, and would overhang the way I wanted it to. I had some issues with overhang on the top. I'll talk to those as we go a little bit farther down the line. But before you glue or clamp or anything, make sure that you try it in place and it's going to fit the way you want it. One of the issues that I learned a lot about was overhang. My top doesn't overhang quite as much as I think it should, and I would either make it larger so that it does overhang more, or I would make the front and the side panels on the lower section taller so that the gap between the two is less, and from far away, if you look at it, you can see the white of the edge of the door. I would like to cover that up if I did it again. Again, test fit everything before you glue. I use Titebond glue. It works great. The nice thing about it is that if you clamp it, it sets in 30 minutes, so you don't have to every time you glue something, you don't have to let it sit overnight. It's kind of forgiving. If you do need to take something apart, it's not too hard to get it apart before it has dried overnight. So anyhow, I had 4 of these Irwin clamps that you can see in these pictures. Those things were super helpful. I'd probably buy more if I was going to do it again, but I could clamp a few pieces, let them sit, and I didn't have to use any nails or screws for the vast majority of the woodwork. I used a couple of nails when I installed the side panels just to hold them in place, but once that was done, then no more nails or screws for anything. The only place that if I was going to do it again, I could do it all without any nails, and the only screws I would need would be for the base frame that is made out of the 2x4s. One issue that came up that we'll talk about in a little bit too is make sure when you do your side panels and your top that the back edges of those 3 pieces are all in the same plane, so that when you roll it up to the wall, it all hits the wall nice and flush like a good piece of furniture should. I did not make my top panel go back far enough, and I had to put another piece in place to compensate for that. I'll show you what it looks like. It's not ideal. I was able to cover up my mistake though. Okay, that was the easy part. Now for the tower. The tower is 4 panels. It's kind of like building a drawer. And pretty much the same construction as the lower panels, but I had gotten a little smarter on how these panels fit together. So you'll see that the plywood is, in a couple cases, smaller than the size of the rails that cover it, so that they'll fit together nicely. And if I was going to do it again, I'd probably do an even better job at this, and it would fit together even more nicely, but it went together all right. You'll see how it goes. Everything is glued together. The 4 pieces that are the front, the sides, and the top, and then the back is screwed on so that you can get in there to access the things that are inside the tower. The tower, I did a lot test fitting up with that. I used my builder square. I just used a handheld roofing square to make sure everything was nice and square when it went together. We glued and clamped it 1 panel at a time, get everything fit with a lot of unglued panels in place, making sure it was all going to go together. I firmly believe that your tower will probably be better than mine because I'm just not a real skilled furniture craftsman. And for a lot of the unforgivingness of the surfaces of all the different pieces of wood, a power sander really is your friend to make it look like you knew what you were doing in the first place. Cutting the holes in the top. It's a moment that you have to get a little nervous about when you decide you're going to cut through. The top on ours was about, I don't know, 4 or 5 inches thick. The nice thing about the lid is that it's only foam in there, so you're okay to cut it. Use a hole saw. I'm using 2-inch PVC pipes to manage the openings between the freezer box and the tower. As you can see in the picture on the right, one is taller than the other, and I'll show you why that is in a minute. And then I used a 2 1/4-inch hole saw, and that gave the holes just so that the 2-inch interior diameter PVC fit right through. It's Schedule 40 PVC, so the outside diameter is about 2.4 inches. And the 2 1/4-inch hole saw worked perfectly for that. You just tap them in and they fit great, and they're not going anywhere once you get it down. The tower itself is attached to the top using 3 90-degree angle brackets. I don't think I have a picture of that, but that was pretty straightforward when I decided to go ahead and put the tower in place. Before I did that though, and the tower was all getting put together, I very carefully measured out and drilled the 3 1-inch holes using a hole saw again so I could start putting the plumbing in place. I made sure everything was clean, and then I got I used 3-inch shanks to go through the holes, made sure those were good and tight, and then we're using chrome stainless steel faucets. I repurposed the ones from the refrigerator, so I only had to buy 1 shank and 1 faucet to finish this installation. Here's the electrical part of it. The controller and the fan are inside the tower. The temperature probe, that's the gray wire you see there, hangs down into the box. I have it hanging in about the geographical center of the box so that it gets a kind of an average temperature. That seems to work pretty well. I have a couple of I'll show you little sort of dime store thermometers that are in there too, and you can see that the bottom is colder, the top is warmer, just like you'd expect. There's the fan with its wiring off to the DC power supply that I put onto it, and that circulates air from the freezer box up into the tower. And now you can see the 2 PVC pipes are at different levels so that the air will circulate around the inside of the tower and not just go straight across from one opening to the other. Finishes. This is where I really learned a lot because this is my weak area. I'm not a furniture person. I'm not a super skilled wood craftsman. And so I did my research. I sanded everything down to 320 grit, started at 60 and then went down from there. I would definitely do some things differently here. The biggest thing is, look at the picture on the right. I've got birch, poplar, and oak, and the thing I learned when I went to stain it is that it all absorbs the same stain differently, so you get different colors. The other thing I learned was this birch paneling, it had some areas that just didn't want to accept stain as well as the others, and so in this picture on those lower panels, the birch areas, they actually have another coat of stain on them. I'm trying to get those light colored areas to absorb, and they never really did. If I could do it again, I would probably either do the whole thing out of oak, which took the stain much more nicely than the other woods, or I would paint the lower section some appropriate color that would match up and let the oak section on the top just stand out. Here's a look at the tower now when it's time to put it all together. With the electricals in place, you can see the drink lines coming down. They share that same PVC pipe, and it kind of shows you the overall layout for the whole thing. Picture on the right, you can see how the back was built. I used a hole saw and cut a semicircle there, and then I just put a slit in the middle of that insulating material so that there was no open airflow out the back. Inside I used fiberglass batting, 1.5 inches thick, and then I took some of those envelopes that they give you at the homebrew store to bring your yeast home in, and I cut those to make that silver exterior cladding for it, just so that there's no loose fiberglass going around in the tower. And I had some metal tape like you would use on HVAC that I use to keep all those things together. The panels are removable, so you can slide them out if you need to. For mine, like you have to slide the top panel out to get to the drink lines and everything at the back of the shanks. On the bottom there, you can see a couple pictures from the back of the tower with the back in place, the 2 screws that hold it in place, and then the back of the whole thing. I installed an eye bolt underneath the back of the top material so that I could hang all the power lines there and they didn't drag around the floor, and I wasn't always running them over every time I moved it away from the wall. Some pictures on the inside. A couple good lessons learned here. Number one is, if you saw what ours looked like, it's got the tower and then it's got the handles for the taps which stick out above the top of the tower. First time I ever opened the lid, I didn't roll it away from the wall, and so first the top of the tower hit the wall and broke a picture, and then the tops of the tap handles hit the wall and they both opened up, and I've got beer flowing out, and that's not good. So unless you want to pour beer down the vertical top onto the floor, make sure you pull it away from the wall before you open it up. You got to pull it out quite a ways to make sure that that won't happen for ours. Yours might be different, and so maybe not an issue for you, but you can see even with all that heavy wood on top, the hinges will still hold the top open when it's up vertical like that. I made sure that I dimensioned the drink lines so they're long enough that I can open the top all the way without stretching anything. And then if you look at the picture on the right, a couple of inexpensive thermometers in there to kind of monitor what the temperature is. They're not super accurate. I think the controller thermometer is much more accurate, and it's set right now I think to be between 35 and 38 or something like that. And seems to work just fine. Doesn't cycle it too much. On the controller too, I set a 1-minute anti-recycle setting on the controller so that the compressor has to be off for at least 1 minute before it'll restart, and it won't just cycle all the time in case it is cooling down. But mine, it runs maybe once an hour or something like that. Probably even less in the house now. Okay, lessons learned. You've seen our basic process. Very straightforward, I think, in the long run. And just want to put it all in one place for you so that your Keezer build comes out well. Overall, though, here's some of the stuff we learned. We already talked about wheel locations and how critical they are. You might try to use a different kind of wheel based on that as well, but the standard ones I used, you got to make sure they have good clearance. I would definitely extend my side and front lower panels a little higher up so that when you step away, you can't see the white edge of the lid. I would definitely think about using all oak on it. The downside of that, of course, is that oak is really expensive, and so this would have cost a lot more. My overall cost for this thing, all materials included, was less than $200, so I had to keep it in budget. You could definitely just use construction adhesive everywhere and not have to screw anything into the sides of the front of the freezer. Reduce your stress and tension a lot if you do that. You need long bar clamps to do that too. I learned about those, and I would definitely get some if I was going to do this again. The fan in the tower does make a little bit of noise. We're noisy people, so it doesn't bother us at all. However, if you're in a really quiet location, you do have the option of putting that fan on the bottom of the PVC pipe inside the freezer box and letting it run from there. I think it will be a lot quieter down there too. The top dimensions, we already talked about, making sure that the back and the sides, if you look at this picture, the back edge of the top, you can see that trim piece that goes across. That's because I didn't make the back of the top piece line up with the sides backs so that when you rolled it up against the wall, there was a gap between the top and the wall, and it looked funky, so I added that instead. It's nice because it continues the lip all the way around so it'll catch any spillage or anything, but it doesn't look as nice and clean as it could if I would have designed the top correctly in the first place. So lesson learned. I had all my shanks come loose after I put everything in the tower and had it in place and everything, so make sure you install them nice and tight the first time. You won't have that issue. Some people use Loctite. One thing I learned too is that in the garage installation, I had the gas bottle outside the refrigerator. It stayed warm, and that helped it last a long time. In this installation, the gas bottle's inside, and so it gets cold, and that drives the pressure down on it. I think that means I'm not going to get as much use out of the gas bottles as I did before. I just put a new small gas bottle in there. And, you know, at room temperature, it was about 800 psi. At freezer temperature, about 40 degrees, it's about 500 psi, and so we're going to wait and see how that works out. Ideally, the gas wants to be warm, and if you made a bigger cabinet with outside space outside the freezer for it, you could keep the bottle at room temperature, and I think it would work much better if you did it that way. So, lesson learned on our part. Okay, folks, I think that about wraps it up. Please let me know what you think of this. I'd love to get your feedback and insights because I know a lot of you have experience with this. And if you're looking at a Keezer build, I hope this gave you some information that will help you to do it better. you can contact us, send us a message, and also if you have any questions or things that you'd like to share with us, let me know as well. Hope you enjoyed this, and we will talk to you again soon.